Alrighty, time for an medium. Continuation from yesterday, minimum number of pushes to type word part 2. You're given a string word containing lowercase English letters. Telephone keypads can be mapped with a distinct collection of lowercase English letters, which can be used to form words by pushing them. For example, key 2 is mapped with ABC. We need to push the key 1 time to press A, 2 times to press B, 3 times to press C. Is allowed to remap the keys number 2 to 9 to distinct collections of letters. The keys can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find minimum number times keys will be pushed to type the string word. Return the minimum number pushes needed to type word. Okay. This is the same examples as yesterday, except there can be repeats. So a bunch of junk, 24. Yeah. It can be shown that no other mapping can provide a lower cost. Okay, so minimum number. Okay, this is medium, closer to medium easy, I think. Generally because I think it's going to be pretty obvious that you want to use the highest frequency letters to be the starting the starting one press of each of 2 to 9. So like if X, Y, Z is your 3 highest, then like X should be the start of one press of like number 2, Y for number 3, 4, Z for number 4. So I think it's just sorting by the frequency of the letters in the word. And then the top 8 are the starting letters. And then the next 8 goes into 2 presses, the next 8 goes into 3 presses. All right, so counts is going to be the counter of word, which is going to give me a mapping of the letter to the frequency of that letter. And then the first 8 are going to be one press. Okay. So let's say answer is the count of the total things. So I just need to sort by the frequency. Sort by the frequency. So I think counts.values is going to be the frequency or the values in the mapping. So I think I just need to have a list, right? I just need to have a list from that. So let's say the frequencies is the list of counts. I guess it should be sorted. Sorted is going to return a iterator. Sorted of counts.items, I want to say. And then I'll just go ahead and print out the frequencies to verify that that is correct syntax. Missing a closing paren. Well, it should be counts.values. I even said that. Okay, 444. Okay, it should be sorted reverse. I think maybe this is the wrong order. Yeah. Need to have the array as the first argument and probably reverse as another later parameter. Okay. So the first 8 is going to be one press. The first 8 frequencies is going to be one press. And the next 8 frequencies are going to be 2 presses. So let's say for every frequency in the frequencies array, I guess I probably need an index here. Let's say index in range of the length of the frequencies array. Then the answer is going to increment by the frequency, which is going to be the frequencies at this index, times how many key presses this would take. And I think that would be 1 plus, so 0 through 7 should give me 1. I think it should be the frequencies, this index divided by 8, because there's 8 different keys, 8 different buttons on the telephone or on the keypad. 0 through 7 divided by 8 is 0, 0 plus 1 is 1. And the next one's, yeah, okay. And I think I just returned the answer at that point. All right. Simple enough. Could I have done this faster? So count to get the counter, get the frequencies. I mean, I guess I could do, I do a sorted right here. I could, instead of doing this step, which I'm not sure if it's actually slower or faster, or I guess count that values is what I'm trying to optimize here. Maybe if I didn't have to, because I think that creates a new data structure, iterator. So I think maybe I can do something like list of sorted of just counts, where the key is lambda x. So using the tuple, but the first element in the tuple, which is the frequency of the mapping, and then reverse equals true, and then do the same thing after that to get the number of presses. I think that would work. Okay, it's not a tuple, is it? Is it a tuple? String index out of range. String index out of range. Let me write count of 0. String index out of range. X. Yeah, that doesn't work. If it's not a tuple, it's a mapping key value pair. I guess if x is the mapping, then I do x dot value instead. It's because x is a key. No. Oh, this is not the right syntax. There's no value in a string object. Is it a string? All right, this is just not going to work. So I do the values. I wonder if it's better just to convert it to a list first and just sort the list. I wonder if it's better to I could also use list comprehension. Okay, so I mean the other thing is just like doing this, just converting to a list, and then frequencies dot sort reverse equals true. I mean it should be the same. If this doesn't improve it at all, I'm done. It's made it worse. Okay, excellent. Made it worse by 2 milliseconds. 2%, 1%, probably within margin of error. Okay. All right. Or not margin of error, within variance. Summary. So very similar to yesterday's, except with repeating letters instead of unique letters in the word. Basic logic to assigning letters to minimize total presses is to give the 8 highest frequency letters to be the start of this be the start of their key mapping. Then the next 8 highest frequencies letters to be the second of the key mapping. Where the key mapping refers to the letters associated to a particular key on the numpad from 2 to 9. So need to sort the frequencies, use a counter or create a counter object based on the words, i.e. find frequencies of each letters. Iterate over the frequencies or sort. After sorting, iterate over the frequencies from highest to lowest, and for the first 8, have it be 1 press. So for that letter, frequency times number of presses gives total presses for that letter. Kind of use modulo arithmetic to get the number of key presses based on index, which is based on the ordering of the frequencies. Right? I mean, it's pretty straightforward. Product of the frequencies of the letter times how many key presses that letter needs is going to be the total number of key presses for that letter, and then iterate over all the frequencies, which is iterating over all the letters. Complexity is going to be O of n log n in order to sort the frequency. Frequency array. From there, it's O of n to calculate the number of presses. So overall, O of n log n. Space complexity is going to be O of n to store, is O of n? Yeah, to store the frequency. It's not, frequency is just O of 26. O of 1 to store the frequencies. Since it's at most a 26 sized array, you're keeping track of 26 counts.